Okay, in this video I'm going to talk about how to solve a parallel circuit. So again, we're going to use Kirchhoff's law to predict the current coming out of the battery and the voltages on these different resistors. The parallel circuit actually is a little bit easier to solve than the series circuit. In a way, we can think about this as if it's three separate circuits. So if I consider a closed loop around the circuit, I can go up here, and down here. And what I can see then, if I'm going to call this resistor 1, is that if I go up 10 volts here, I have to get back down the same amount by going just through this one resistor. So if I have to go up 10 volts here, then this resistor actually is going to have 10 volts down on that one resistor. So here, up 10 steps, down 10 steps gets me back to the original location. In fact, this is true of all of the resistors in this circuit. I can imagine taking this path, for example, and I would be going up the 10 volts of the battery, which means I have to come down the full 10 volts on this resistor 2. Finally, in resistor 3, same idea, going all the way around the outside, going up 10 volts here, I have to come down 10 volts on that one individual resistor. So in a sense, I can think of this parallel circuit like three individual simple circuits where the battery is supplying 10 volts to each individual resistor separately as if it's in its own circuit. Now, I can find the current at location 1, 2, and 3 using Ohm's law. V1 equals I1 R1, and unlike in a series circuit, I can't assume that these currents are all the same because they all represent different pathways. So 10 volts acting on a 10 ohm resistor, isolating the current, I get that the current at location 1 is 1 amp. Similarly at location 2, V2, I2, and R2, my 10 volts here is acting on a 5 ohm resistor. Again, isolating for the current. I can see that I2 is 2 amps. And finally, in my last situation, V3 is equal to I3, R3, and my third resistor. My 10 volts here is acting on a 20 ohm resistor, isolating from my current. I see that I3 is half of an amp. So this all makes sense. Most of the current goes down the path with the least resistance. Some goes down this one, and then less goes down this one, which has the highest resistance. The question asked us to predict the current coming out of the battery, so we also have to find what I'm going to call IB right here. To do that, I'm going to consider this junction right here and recognize that the current from the battery has to supply the current for resistor 1, and the current from resistor 2, and the current for resistor 3, or the total amount of current going into this location has to be the same as the total amount of current coming out. So if the battery has to supply all three of these, then the current through the battery must be the sum of the three. 1 plus 2 plus a half is 3.5 amps. So for a parallel circuit, that's how we can find the current out of the battery, as well as the voltage and current in all three locations.